Good morning, everybody. My name is Timothy, and today I'm here with my groupmate Aijun. We're from Group O, and today we'll be presenting about the net zero energy building, the Crystal from London. Here are some details of the Crystal. It's built by Siemens Corporation, commissioned by the architects Wilkinson Eyre, and completed in the year 2012, started using in 2013. So I'll firstly briefly talk about what we'll be talking about today. What is a net zero energy building, some differences between the passive and active architecture, and also some of the milestones that have been achieved by the Crystal in being a zero energy building and also a sustainable building. Next, we'll be talking about the main feature of the Crystal, which is building energy management system. First off, we must understand what is a net zero energy building. Net zero, as the name suggests, is actually a building with a net zero energy consumption, or you could understand it as the total renewable energy produced by the building and its systems are equal to the energy used by the building during its operation. Net zero energy buildings are said to be the most effective incentive for sustainable development, as buildings actually account for 40% of total energy consumption around the world. Most net zero energy buildings actually use a combination between energy conservation and energy harvesting. Well, that brings us to the next topic, the differences between passive and active architecture. Passive architecture would focus more on energy conservation by using less energy during its operations, while active architecture focuses on overcoming the lost energy by using renewable energy harvesting and energy production. Passive architecture mostly makes use of natural features such as sunlight and wind, while active architecture would make use of mechanical systems. And lastly, passive architecture, it is designed intervention. It requires precise planning and coordination with people from a lot of fields. Whereas active architecture has sometimes higher initial costs to set up the energy harvesting and mechanical systems. Well, some of the milestones that have been achieved by the Crystal include leadership in energy and environmental design, Platinum Award because of the 70% less carbon emissions and 0% fossil fuels usage. It also achieved whopping 86.92 points in the Building Research Establishment Environmental Assessment Method with 90% water self-sufficiency. Moving on, we'll be talking about the building energy management system that is within the building. The Crystal has this energy management system that senses indoor and outdoor conditions and then controls suitable energy efficient ventilation mode for each part of the building. For example, it has this automated windows and skylight. It introduces natural ventilation through high and low level parallel windows and also the stack effect to maximize the air intake and exhaust. At moderate temperatures, natural ventilation is used and the windows and skylights open automatically to allow cool air in and hot air out. Moving on, the Crystal also has this weather station which is connected to the building energy management system to monitor the forecast and uses indoor sensors to track the temperature, humidity, and carbon dioxide levels inside the building. The rain sensor on the weather station connects to the automated windows and skylights, which close automatically during the rain. In the Crystal, almost every space in the building has access to natural daylight, meaning minimal artificial light is needed. Even so, the lighting system in the Crystal uses an advanced control system produced by Siemens, which automatically adjusts every individual lamp to provide comfortable brightness levels without wasting electricity. Daylight and presence detectors will dim the electric lighting or turn it off when opacity detectors detect sufficient natural lighting.
Now, moving on to the ground source heat pump. Two 300 kilowatts electric ground source heat pumps are used to supply all of the building's heating and most of its cooling. The system works by pumping water through a pipe that loops deep into the ground. There are 199 pipes at the Crystal, totaling 17 km in length and reaching as deep as 150 meters. The temperature below ground is higher than the temperature on ground during winter. Both reach deep into underground to collect groundwater, which supply to the structural piles for heating and cooling. Cold water passes through structural piles for heat exchange. Hot water flows from pipes to underfloor pipes to heat up the building. The heat pumps transfer cold air in the building into the structural piles. The temperature below ground is lower than the temperature on ground during summer. Cold water is allowed to pass through structural piles for heat exchange. Cold water is pumped from the pipes to underground pipes and chill beams for cooling the building. Cold water passes through a ceiling-mounted beam, so when the rising hot air reaches the chill beam, it cools and sinks, bringing chill air to those below. The heat pump extracts heat from the building and transfers it to the ground. Let's move to rainwater collection. Rainwater is collected directly from the building's roof through 4 mud columns which have integral 200-meter diameter stainless steel drum pipes to deliver the rainwater into a 60,000-liter underground storage tank. Then, water is treated using filtration and ultraviolet disinfection to be converted into potable drinking water and hand washing water. Low-use water tap is used in this building to reduce water usage. The building is 90% water self-sufficient and is the first commercial building in the UK to have an approved drinking water safety plan. Now I'm going to talk about black water and grey water system. Black water and grey water are collected in a biological tank which pass through anoxic treatment zone and aerobic treatment zone. Anoxic processes are typically used for the removal of nitrogen from wastewater. Some wastewater has high nitrites and nitrates content, and the treatment process must break down those compounds to avoid causing nutrient pollution when the plant discharges its effluent back into the environment. Microorganism is used in aerobic treatment to break down and remove organic contaminant from wastewater. The treated water flows through a membrane filter and a long-life carbon filter, and the water is stored in a non-potable water tank. The recycled water is used for irrigation and toilet flushing across the site. To minimize the water use, smart irrigation system is introduced to detect moisture in the soil. The Crystal is an all-electric building that uses 1,580 meters square of solar photovoltaic panel and a ground source heat pump to generate its own energy. Around 80% of buildings' hot water is heated by a combination of solar thermal water heating from the roof and ground source heat pump, which ready for kitchen use and normal hot water use. 2/3 of the roof is covered in photovoltaic panels, generating 17 to 20% of its electrical energy. The Crystal is an ideal representation of using active architecture and system to achieve near net zero energy. It portrays the challenge of using mostly active system as one of a kind project for future reference. The Crystal has certainly demonstrated its ability in self-sustaining energy and water demands via multiple on-site and off-site system setup, showing that net zero energy building can be achieved by focusing on active system as well.